It's a few hours to IGCSE Cambridge 0625 exam in electricity that you need to remember a few hours before the exam. So we have question number 26, which says a resistor of resistance R is connected to another battery of EMF V. There is a current I in the resistor, and then we are supposed to identify which is the correct expression. So in this area you need to remember the following formulas. We need power is E over T, energy is equals to IVT. Energy is power times time. Power is equals to current times voltage, and the resistance is voltage over current. So in that case, A is the correct answer. So you need to remember that few hours before the exam. Then we have also a copper wire of 80 centimeters, a cross-section area of 0.20 millimeters square, and resistance R. Which length of the copper wire of cross-section area 0.4 millimeter square has a resistance of R? In this case, you need to remember that resistance is resistivity times length of a cross-section area, then which means that we can be able, since they are made of the same material, we are going to say they are made of same material, so we can be able to say we shall make resistivity the resistivity the subject to the formula. So we shall say resistivity is equal to resistance times cross-section area over the length, because both of them are copper wire, so they have the same resistivity. So we shall compare the resistance for resistivity for the first section of the wire and the resistivity of the other section of the wire. Then we equate them because they have same resistivity. Resistivity is equal. So that is exactly what we're going to do. But resistance, we are told the same, we cancel out, and then we are going to make L the subject of the formula, and this is going to translate to 160 centimeters. So you need to remember the concept of resistivity. You need to remember those formulas I've mentioned in the previous section for you to be very comfortable in this particular exam of today. We have question number 28. We are told for identical resistors connected to a battery as shown there. Each resistor has a resistance value of 120 ohms. So we are supposed to told resistor R4, the lowest resistor that we have here, is removed. How is it going to affect the resistance of this circuit? So something that you need to remember here, you need to work out the resistance of the entire circuit before it's removed. Then we are going to realize that when you are going to remove the resistance of the circuit is going to increase. So let's try to work out the resistance. And remember, whenever you are having resistors in parallel, you say 1 over 120 plus 1 over 120 plus 1 over 120 raised to power negative 1, so that you can find the reciprocal, you find the exact answer. So plus 120, because we were having another resistor there that was in series, that's why we're adding also 120. Then if you work it out, you're going to get a resistance of 40 plus 120, which is 160 ohms. Then we're going to remove this resistor we are told, then we are going to again work out the total resistance, and if you work it out, you are going to get it being equivalent to 180. So you can see when that is removed, we are going to have the resistance of the entire circuit increasing by 20 ohms. So we are going to say the answer is going to be C. Moving to the next part, moving to the next question here, question number 29. We are told the resistors in the circuit shown are identical. They are identical. So with the information provided, we're going to say we have voltage here, V2 is 1.5, and current A3 is 0.25, current A2 is 0.5. Then we're going to realize that the total current in this circuit is going to be 0.75. So current in ammeter 1 is going to be 0.75. Then also we need to understand that along here we have same voltage because they are in parallel. Also we have same voltage here, and also down here we shall have the same voltage. But since we have at V2 we have a voltage of 1.5, and there's going to be same current in that same current across that resistor for V2 and same current that we have there A3, then we are going to have 0.25 as the current for the two resistors that are down there. Then we can now say the voltage drop across the resistor that is next to V2 is going to be 1.5. So if we add 1.5 plus 1.5, we are going to get 3.0. So this is 1.5 also, so we shall say this is going to be 1.5 plus 1.5, which is going to be 3.0 volts. So all since the connection that we have here is in parallel, then we are going to have the same voltage. So we are going to say voltmeter V there is going to be also 0.3. Now here we have sound. The particles vibrate parallel to the direction of the wave, and then that's a longitudinal wave. Sound is a longitudinal wave. Where we have strongest magnetic field is where the fields are very close, and that is A. And point C, we have weakest fields at that region. In question number 25, we are told that there is a current of 0.6 amperes in a closed circuit. How much charge passes? We know that charge equals to current times time, and that is going to be, we have to convert the time to seconds by multiplying by 60, and then we are going to say our answer is 150. That is 0.6 times 150, which is going to translate to 1 watt. That translates to 90 coulombs. Which two physical quantities have the unit joule per coulomb? We are going to remember that voltage is energy over charge, and that is going to be EMF and potential difference, because potential difference is also measured in volts, and EMF of a cell is measured in volts as well. 1 hour before the exam room, you need to remember that. 1 hour before the exam room, you need to also remember how to work out with copper wire and resistance. So we are told a wire, if the length of the wire increases, if the length increases, doubles, the resistance also doubles. If the diameter, if the area decreases by a half, if the area halves, resistance also doubles. If area halves, resistance doubles. If diameter, if the diameter of the copper wire is a quarter, it means diameter is directly proportional to area. So which will mean that if you reduce the diameter by a quarter, you are going to reduce the area by 1/16, because you remember area is pi r squared. So if you reduce the diameter by a quarter, you are going to reduce the area by 1/16. So in that case, if area decreases, also resistance increases. So in that case, we are going to say, because the length of the copper wire is twice L, so it's going to be 2 times 2. Resistance is going to be times 2, and then now the diameter is a quarter, so we are going to say a quarter squared, that is going to be 1/16. Then the resistance is going to be times 16 in that case. So we are going to have it as 1:32. 1:32 at that point. Which circuit contains diode connected in series in a fixed resistor? This is C, because you see a fixed resistor is having that kind of setup as C, and the diode is well represented there. So the correct answer there is going to be, for a diode and the fixed resistor, is going to be C. The circuit shown, resistor X, has twice the resistance resistor Y. So if there is high resistance, less current is going to flow through that section. So less current will flow through X, because resistance opposes the flow of current. So less current is going to flow through X. But since these two components are connected in parallel, they are going to have the same voltage or the same PD. So we are going to say which statement is correct. The potential drop across that. So we are going to say that if this is R and 2R, and then we're going to say our correct answer in this case is going to be A. Current in the cell is greater than current through X. Yeah, so B is wrong because current in X is greater than current in Y. That's not true, because if there is high resistance in X, it means low current will be in that section. And also potential difference across the cell is greater than that of X, because X and Y are parallel to the cell. They all have the same PD. You remember this 1 hour before the exam. So we need also to look at this. We're told that we have a 4 ohm resistor and 8 ohm resistor connected in series to the power supply. A voltmeter connected across the 8 ohm resistor read 36 volts. So if it's reading that 6 volts, then what we are going to say is that this other resistor is going to have a voltage of 18, a half of that. So this is going to be the answer. Our answer is going to be B. The answer is going to be B, because both of them will have the same current, but the resistance are different. So if 8 has that, this one is going to have what? 18 volts. And the working is shown there. So we need to move to that section. We're told metal rod. In which direction is this going to show? In which direction? The correct direction is you are going to use Fleming's left-hand rule, and then we are going to get to say you are going to do this. Yeah, you are going to do this. Start doing this. In exam, you'll be seeing people doing this. Well, right, so it will be out of the page. So I believe we are going to do this kind of things. So in order to get that, and then we are supposed here to identify the parts. This is the coil. We have here the split rings, and this is the commutator, and then we have these end brushes, and then that's the answer is A. Then we are also supposed to work out that, and we are supposed to remember there number of turns in the primary coils over number of turns in the secondary coil is equals to voltage in the primary coil over voltage in the secondary coil. Also, we can be able to say number of turns in the primary coil over number of turns in the secondary coil is equals to current in the secondary coil over current in the primary coil. So in this case, we are supposed to use current, because in the question we are having current, we shall say current the secondary coil over current the primary coil. And that is exactly what we're going to do. We are going to connect the two transformers that way, so that the output here is 0.2, and then we can be able to say 2000 over 1000 is equals to current in the secondary coil is 0.2 over this section. We are going to say we shall have 0.2 times 1000 over 2000. We shall see that the current will be 0.1. So meaning it here is 0.1, this one is going to be a half of that, 0.05, and the correct answer there is that. Moving to the next part, we are going to say student determines the resistance of a resistor. She uses this, so we are going to say which is the best circuit to use here. A resistor should always be connected in series with a component, and sorry, what am I saying? An ammeter should be connected in series with the rest of the component, while the voltmeter must be connected parallel to the component where we want to measure the voltage. So remember that 1 hour before the exam, that must be remembered. So moving to that, the correct answer here is D. You can see ammeter is in series, voltmeter is in parallel. That's exactly what they were testing at that given point. And when we have a diode in such a way that current is going to flow from X to Y, because we are told at X that's where we have high voltage, higher PD, potential, maximum potential difference, so meaning current will flow in that direction. And when that happens, it will be in reverse biased with the diode, and that will mean that current will not be able to flow in that section. So meaning if we are going to draw this, current will not flow for some time until current starts reversing, and that is, in that case, we are going to say that if we work it out, let's go and work it out with the graph, how it's gonna look like. Let's see, the graph is going to behave this way. Let me just move this down. 1 hour before the exam, you have to remember, when the diode is in reverse biased, current is not going to flow. So in that way, we're going to have our graph going like that, no current flowing in that case. So current will remain here for then, if then it will be able to decrease like that. So we shall have our option D at that given point. So when a conductor in a complete circuit, when a conductor in a complete circuit cuts across a magnetic field, a current is induced in the conductor. And then we are going to use Lenz's law. Then the direction of the induced current will try to oppose the change causing it. And that is going to be what? D as the best option in that case. Moving to question number 29, we are going to assess the magnetic fields inside that, and we are going to say inside this point X and Y, they have the same magnetic fields, and but outside here we have weaker magnetic field, because the magnetic fields in this case are gonna look like that. And then we are going to say the best answer is what? A. A conductor that is in the magnetic field, so we are going to say when the current is towards, so you can see there are three statements given there. When the current is towards the top of the page and the direction of the magnetic field is unchanged, the force induced is act into the page. Initially it was out of the page, but when it's the current is reversed and the fields are left that way, the force is going to be into the page. And that statement is very, very correct. So that statement is correct. We can be able to agree and we say this correct. When the current is towards the bottom of the page and the magnetic field is reversed, the force produced acts into the page, which is also correct. And you can be able to use this, you can be able to use Fleming's left-hand rule in order to determine the direction of the forces, because for a motor we use Fleming's left-hand rule. For generators we use Fleming's right-hand rule. Yeah, so you don't confuse those rules whenever you are going to do that exam. Fleming's right-hand rule and Fleming's left-hand rule. Yeah, so that is it. All the statements are correct. Which type of electric current is produced generated in step up transformer? Both of them are alternating current, and we say that alternating current creates magnetic fields which are constantly changing size and direction. Then when those fields cut through the secondary coil, an alternating current also is induced through electromagnetic induction. You should remember that before you enter that exam. Then we have with scientists fires alpha particles in a at a very thin sheet of gold and detects particles that pass through. Then the statement that is correct there. Of course this is not electricity, but I said let me just, because it was just next, we can be able to identify that. And magnetic fields, electric field rather, is the question, because the positive ion are attracted to plate P. It means this is negatively charged. Then we are going to say the fields gonna look like that, and we shall have the fields looking that way, and that is C. We have question number 26. You need to remember this before you enter the exam. How much charge is equals to IT, and you need to remember that how much energy, sorry, not charge, energy is equals to charge times voltage, or the PD, and then we're going to check. We have voltage there and we have charge, then we're going to multiply the two guys, and that's 10 joules. And remember this formula before you enter that exam. Then for the diagram that represents a filament lamp, that is basically A. B is representing ohmic conductor. D is representing what's that? Does this even represent anything? Okay, just let's just move. Yeah. And then the diagram shows a circuit, and which statement is correct? Which statement is correct? This correct statement here is that ammeter A has the highest reading, because ammeter A, to get the reading for ammeter A is the reading of A2 and A3. You add them together, so remember that. Then we have the connection here. With this connection that is going to give us a parallel combination is going to be B. In that case, that's how we shall work it out, and that's going to be B. And then we have an electrical engineer made a pair of components P and Q, and this is the conditions. P, resistance of P decreases as temperature rises, and resistance of Q increases as temperature rises. So which statement is going to be correct? Yeah, which statement is going to be? For A, the sum of the PD across PQ does not change with temperature, so we're going to say that if the temperature change causes the PD to double, then PD will halve. That's not quite. That's not true. Yeah, because if we are told that and in that case we are going to say the correct answer there is D. And finally we have the last bit of the question, the last part of the question here. Yes, so the first part of the diagram that we have here, you were supposed to use Fleming's right-hand rule to determine the direction of the current. Now, if you use Fleming's right-hand rule, then it means the induced current will be flowing from X to Y. Then now to determine, the current will be generated, and that current will be flowing from X and Y. Then for you to determine the force, the direction of the force, you use Fleming's left-hand rule, because the current will be there. Then now you use Fleming's left-hand rule, and then you realize the current is going, the force is going experienced, because current will be going that direction. The force experience will be acting downward. So current will move from X to Y, and the force will be acting downward, and that is going to be A for that case. Okay, so one hour to the exam, you also need to remember that okay, let me just move this. We are rushing against time. Last minute rush. So checking to see why is it not moving. Okay, so the last part of the question here, since it will be stationary, so the galvanometer will point that way, as it will be moving out of that, the current will be, it will deflect to the opposite direction to the past. So that answer is going to be there. The correct answer there is going to be B.